front of me are scaled down models of world-changing 3D prints in 7 different levels. We are going to go through them and I will show you why one day they might change your life. To start off, we have this. This is a scaled down model of a city. In Saudi Arabia, they're currently working on a project called The Line. A few years ago, they showcased this 3D printed model of the project. But this print is more important than either. First of all, when a model like this is 3D printed, it allows engineers and designers to spot weak points much easier. This allows for a much faster iteration, which leads to quicker decision making and an overall faster production. It also gets investors really excited. This isn't actually printing the project, but it's printing the prototype. Though, if you're interested in printing a full city, you might want to stick around for level 4. This is only scratching the surface, because level 2 is much more awesome. Level 2 is 3D printed cars. Traditionally, starting a car company requires billions of dollars for all the designs, parts, factories, and the massive teams required. But with 3D printing, the barrier almost fully disappears, which allows for a much more competition and results in a better, more affordable product for the consumer. Instead of one huge factory, we could start seeing many micro factories in cities around the world where cars are printed locally. That means less shipping, lower costs, and much less pollution. It also changes how cars are designed. With 3D printing, engineers can create lightweight, bone-like structures that use far less material but still stay just as strong. For electric cars, this is huge. Less weight means longer range, sometimes adding dozens of miles on a single charge. Even repairs could completely change. Instead of warehouses full of spare parts, companies could just store digital files and then print on the spot. If you need a new door, you could place an order for a new door and it will print overnight, and the next day it could be installed on your car. And because 3D printing only uses the material needed, waste will drop dramatically. We could even see cars being fully recycled. Just melt the material and print a new one. For level 3, we're scaling down and entering the medical field. This is, or at least was supposed to be, a surgical guide that has the potential to change operations forever. A few years ago, a surgeon preparing to remove a tumor from someone's jaw would study an MRI of the patient and then create a mental map of how to pull off the surgery. Then during the surgery, they would have to translate those mental 2D images into a 3D. Every cut was based on experience, estimates, and constant checking. Now imagine the same surgery today. Before the operation even begins, a 3D scan of the patient is printed into Before the operation begins, a 3D scan of the patient's jaw is converted into a physical model. From that, a custom 3D printed guide is made. In the surgery, it perfectly snaps onto the bone like a puzzle piece. The surgeon's saw can only move through built-in slots that were prepared weeks in advance. What once could take hours will now take less than an hour. Less time under anesthesia, and far fewer live x-rays. And this physical bridge between digital planning and real-world action is spreading fast. Dentists using these guides already make implants quick and safe, directing drills to avoid nerves and sinuses with millimeter accuracy. In forensics, printed bones allow investigators to reconstruct trauma, fitting pieces together to understand impacts and bullet paths without actually damaging real-world evidence. Now, have you heard of Dubai's new goal for 2030? They hope to have 25% of all new buildings fully 3D printed. 3D printed homes have been in discussion for years because they are cheap, better for the environment, and much faster to build. But what was once an idea is finally starting to turn into actual reality. In Texas, a place called Wolf Ranch is becoming the first in Texas, a place called Wolf Ranch is starting to become the first 3D printed neighborhood. Nearly 100 homes are being printed. And these aren't some low and these aren't some low end and these aren't some low end homes either. These are large these are large 2000 square foot homes. These are large 2000 square foot modern homes that are as durable as concrete ones, and for a fraction of the price. For a fraction of the price. Back to Dubai's goal. You're looking at printing smart benches, bus stops, and even components for bridges. The goal is to turn the city into a living lab of zero waste construction. Some projects are even printing the homes directly from the earth. In Italy, printers are using the soil from the ground to print dome-like homes that not dome-like homes that naturally stay cool in the summer and warm in the winter with virtually zero waste, and warm in the winter with almost zero environmental cost. But if we want to take it a step further, NASA is reportedly partnering with one of these companies with the hope of printing a base on the moon and hopefully one day on Mars. With the hope of printing a base on the moon and maybe in the future on Mars. Speaking of space, up there, 3D printing is quietly becoming one of the most important survival technologies that astronauts have. Launching anything into orbit costs roughly $10,000 to $20,000 per kilogram. That means every wrench, every replacement part, every tool. Every piece of equipment is incredibly expensive and slow to deliver. If something breaks on the ISS, then astronauts are required to basically just wait for months until they can get a new one from Earth. But 3D printing changes that. Back in 2014, the space station printed its first tool, a small racket wrench. An astronaut needed a specific part. Engineers on Earth stayed overnight designing the tool, and then they sent it up to space and he printed it in the space station. At first, these prints were made from plastic. It was a proof of concept. Recently, though, astronauts installed the first metal 3D printer in space. Instead of plastic filament, it uses stainless steel wire and a powerful laser to melt it. This is a massive step forward because metal can handle the space. This is a massive step forward because metal can handle the heat, pressure, and stress of a real spacecraft repair. But it gets even better. One of the most impressive machines on the ISS is called the Refabricator. It's part recycler, part 3D printer. Astronauts feeded old plastic packaging and other waste. Astronauts feeded old plastic packaging and other plastic waste. And the machine melts it down and turns it into usable filament. This creates a closed loop system in space where almost nothing gets wasted. In an environment where every grain matters, this is of course huge. And for future missions to the moon and Mars, 3D printing will become crucial. We can't bring tons of concrete, steel beams, and other building material millions of kilometers across space. So instead, scientists have been working on something called living off land. Robotic printers will use lunar dust and Martian soil by melting or binding the soil together. They can print landing pads, roads, and protective habitats. These structures are already perfect for space because the material itself can block deadly radiation. Instead of shipping cities from Earth, we'll just print them wherever we go. In space, 3D printing doesn't make things cheaper or faster to make, but it does make human life beyond Earth possible. Up until now, we have seen how 3D printing can assist and change machines and infrastructure. But now this is level 6. But now this is level 6, and we're going to explore. But now this is level 6, and we're going to explore how 3D printing will change the human body. Today in 2026, engineers are working and have already had some great results with something called bionic engineering. Basically, structures inspired by how our bodies construct tissue. Bones and tissue. Take medical implants. In the past, if you needed a titanium hip or a bone plate, it was a smooth piece of metal. It was a smooth, solid piece of metal. It was definitely strong, but your body often treated it like a foreign object. Over time, implants could loosen cause more pain, and require further surgeries. Now with this, now with 3D printing, now with 3D printing implement, now with 3D printing implants are made with microscopic lattice structures that look like tiny sponges. Because because printers can layer material layer by layer, because printers lay material layer by layer, they can perfectly control the texture. The surface of the implant can actually mimic real bone. Your natural bone cells your natural bone cells grow into your natural bone cells grow into these tiny holes, locking the implant in your skeleton, which allows the implant to basically merge with you. But metal isn't the only option. Scientists are now print scientists are now printing implants with polymers like scientists are now printing advanced implants with polymers like PEEK, which is a material with which is a material with a similar flexibility to human bone. This prevents something called stress shielding, where metal is actually too strong, causing the surrounding bone to weaken because it takes off so much of the pressure. Even more futuristic are bio-reusable implants. These are 3D printed supports. These are 3D printed supports that hold the bone together as it heals. Then it slowly naturally dissolves over then it slowly nat- then it naturally dissolves over a u- then it naturally dissolves into the body after a year or two. Then there are prosthetics. Modern 3D Modern 3D prosthetics are custom made to fit each patient's exact anatomy. Inside them, printers create hollow channels that hold wiring and sensors directly within the structure. When a person flexes a muscle, electrical signals from the skin are translated into actual movement, opening fingers, rotating the wrist, and controlling grip strength. And soon these same prosthetics will send signals back. The patient will be able to feel pressure and know how tightly they're actually holding something. Some researchers are actually working on something called 4D print. This doesn't enter another physical dimension, but rather the dimension of time. These materials are capable of slowly changing and morphing over the course of multiple years. Young children can grow out of prosthetics within a matter of months. Replacing them is expensive and a hassle. But when the prosthetics can grow with them, they can last for years. The line between machine and human is starting to really blur. But let's blur it more. Because we're going to be talking about printing actual living tissue. To understand where this is heading, it helps to walk through the 3 stages of evolution of this stuff. The first stage is where we are currently at with technology. Right now, we're not capable of printing actual organs yet, but we're printing flat layers of tissue. But we are already printing simple flat tissue that doesn't require large blood vessels to survive. Surgeons surgeons have successfully implanted 3D printed ear. Surgeons have successfully implanted 3D printed ears made from a patient's own cells. And for really bad burns, printers can print thin layers of skin tissue that can go directly onto the wounds. Instead of plastic, these printers use something called bioink. You can think of it like a gel mixed with living cells. The reason we can't print thick tissue yet is because the reason we can't print thick tissue the reason we can't print the reason we can't print thick the reason we can't print thick tissue yet is because is the reason we can't print the reason we can't print thick tissue yet is because the layers in between would suffocate without blood vessels bringing in oxygen. This leads to stage 2, where we're hoping to be within a decade or two. This leads to stage 2, where we're hoping to be in a few decades. Scientists hope to move away from donor lists and print actual organs. Imagine a lab within a hospital where the doctor can take some of your own cells and then print you a new kidney. The real breakthrough will be to print tiny blood vessels that could go between the cells. The real breakthrough will be to create tiny blood vessels that can be printed within, so the layers in between don't suffocate. And once that happens, we could grow any organ, a heart, a liver, a kidney, and it will be 100% genetically matched to the patient. In this scenario, there's no worry about you having to wait for. In this scenario, there's no worry about your body rejecting the organ or being the rest of your life on medications, or even the extremely long waiting periods. Then comes the extreme feature, stage 3. In theory, advanced printers could one day print full biological structures using light-based volumetric printing instead of layers. This means printing a full human body. Using your own DNA. Now, aside from that being a bit weird, there's also a catch. While we could print the structure of a brain, we can't actually print memories or consciousness. It would be a biological twin with a blank mind. More realistically, the extreme use would be internal repair. Tiny robotic printers could enter your body through incisions, and they could rebuild damaged tissue while you sleep, fixing organs before they even have the opportunity to fail. The future is going to be exciting. I recommend you stick around for it. Bye now.